In addition, the other half of the equation, as far as dispersion, would be chemical. There are various chemical approaches you can take to keeping a dispersion stable and into as close as possible its native state. One of the basic rules of thumb for sample handling and dealing with all particles, as a general rule, is that things that are above 50 to 75 microns, generally they don't have aggregation problems. They have a problem which would have to do with sample sampling, which means they can actually form, they can self-segregate into a size distribution, so that you have to keep moving it physically around. Otherwise, if you were sampling from the same place routinely and never dispersing the sample by physical method, you could begin to see a systematic decrease in size, because the smaller particles will percolate to the bottom of the container, and you'll see things that used to be 30 microns are now 28 microns, and now they're 25 microns, and suddenly you find out that you're wondering what's going on. And what you've done is, by not changing those large particles and rotating them in some fashion to keep them mixing, the small ones percolate between the spaces between the larger particles. And this is something that's known as, it's been called self-segregation. They segregate into a size distribution, but it is a discrete one where the bottom is small particles and the top is big particles. Now, on the other hand, small particles have also a dispersion characteristic, and that is when you start getting into the colloidal range, which is below a micron, you start seeing a dramatic increase in agglomeration where particles stick together. So smaller particles now appear as much larger particles in a size analysis, because they clump together due to something called van der Waals attractions. And these are close physical chemical reactions, not chemical but physical reactions that cause them to stick together and be attracted to each other. So that's why when you have very fine particles, the things that are very free-flowing, and they will very often stick to the containers. You'll see the various types of materials where you have fine powders and they tend to cling to everything. And that's because they cling to themselves and they cling to other objects because of these van der Waals influences. Now in this case, sonication, ultrasonication is a possibility, physical methods, but you may often have to resort to chemical methods. And the chemical methods would include things like surfactants. And a surfactant is basically an additive that you put into a liquid suspension and now has its individual molecules can be charged positively, negatively, or they can be non-ionic. They may have no charge, but they contain large physical groups on them, like large benzene type rings, structures, or long elongated hydrocarbon chains, which act like arms and actually physically keep the particles from coming together. So these surfactants bind to the surface of your particle of interest and prevents it from interacting with other like particles by the surface chemistry effects. And in the case of the positively charged, you get charge repulsion as your friend in this case, where two positively charged and coated particles will repel each other as they reach proximity, and therefore you keep them in suspension by effect of adding either a positive or negatively charged surfactant. Some of these charge effects can be done even without benefit of adding a surfactant, which maybe that isn't something you can tolerate and the customer can't tolerate in a process. So they can do things like change the ionic strength. They can increase the amount of salt inside a preparation, or maybe they have to decrease the amount of salt in order to keep particles that are electrically attracted because they have opposite polarities. Maybe they're long particles and some of them may have positive and negative charges, and then that can cause them to agglomerate. Or you may simply adjust the chemical environment by adjusting the pH of the solution with buffers and control the pH. So these are methods, these are chemical methods.